the only day.
All right, friends, let's see where you're at. Let's talk about these and see what you've come up with. So I went ahead and plotted a color coded here. So pink are number 1 and blue are green. Now, on my grid, I did not draw all the circles, so you had to watch the scale on yours. So for me, my third circle out is 3, but for you, it was, the farthest circle out there. So does anybody gonna make any mistakes with any of my points, or does anybody have a question about any of those? So you should look at your problem 1. Are your points for problem 1 like where mine are? If not, we need to discuss it. And then problem 2 is the greens. And then problem 4 are the blues. Problem 3, I mean, are the blues. Anybody have a question about that? Okay, so for example, quickly talk about this for problem 3, that point that was -2 pi over 3, you can't plot a negative radius, so you're gonna think about it as being a +2, but when you change that radius, you're flipping your angle across halfway around the circle. So you're going from -2 pi over 3 to maybe +pi over 3. And that's why that point's plotted right there. Right? Remember that? The whole -r thing? Okay. All right, so you needed to use that for the next one. So problem 4 and 5. It said get 2, but there are so many that some of you probably came up with some other options. So give me an idea. What did you come up with for number 4? One other way of rewriting that point. Give me one for number 4. 4 -7 pi over 6. Beautiful. If you want to leave r as +4, then all you're going to do is add or subtract 2 pi's. So he subtracted 2 pi. Did anybody say 4 17 pi over 6? Would that be another one?
That's what I said.
Perfect. Now what about give me a couple with negative r's? If I'm going to change the sign, this is my original. If I'm going to change the sign on r, then the angle's going to change by pi. So you could say, what, 11 pi over 6? Or -pi over 6? How do those look? Did anybody have a different one than any of those that we need to talk about? All right, tell me what you got for this one.
3 and pi over 4.
3 and what?
Pi over 4.
Pi over 4. So he said, I'm changing my r to positive. That's going to change my angle by pi. He could have done 9 pi over 4. Would that work too? Yep, absolutely.
-3 pi.
So Gabby says I'm going to leave my r negative, and that's going to change, if I don't change the sign on r, if I leave it the same, then I'm going to add or subtract 2 pi. So she subtracted 2 pi. She could have added 2 pi. Is that right? Yeah. Real good. You okay? Good. All right, let's go to the multiple choice now. Who got an answer for 8? We're gonna run through and get all the answers, then we'll come back and answer questions. So, Bennett, what did you get for 8? D?
Yeah.
D. I think he's right. If you think he's wrong, we'll talk about it. Number 10. Who got number 10? C. That's what I got. So we're gonna go with that unless you want to talk about it. Number 12. C again. That's what I got. 14. C again. And 15.
See you again.
C again. we'll talk about any of those you wanna talk about, guys, but we're just getting the answers down now. Number 7, oh my lord, 17 is also C, but not 19.
D.
19 is
B.
B. 19 is B. All right, so who's got a question about one? Yes.
14.
14. All right, let's look at 14. All right, so rectangular coordinates, 3, 0. So that is X and Y. And we are writing that in terms of polar. And we already know there are infinitely many answers. That was what this exercise was all about. There are infinitely many answers we can come up with. We just need to come up with one that matches one of these, okay? So 3, 0. That's an X and a Y, so wouldn't that be right here? 3, 0? Now I need to know the radius. That's easy. What's the radius? 3. And I need to know the angle, and that is 0. So in polar coordinates, opposite radians, in polar coordinates, it's exactly the same. Only this is a radius and this is an angle. Now, that is not an option. All right? So I gotta find one that's an option. And remember, when we start finding options, if we leave this positive, we're gonna be adding or subtracting 2 pies, right? If we make it a negative, we're gonna be adding or subtracting pies. Right? So do you see one that matches in there? See, if you make it negative, then you can subtract or add pi, and you get -3 pi. Does that make sense to everyone? All right, do we need to talk about any of the others? Everybody good with all of the others that we got? 17. Complex number of rectangular coordinates 2, -2. So remember, rectangular coordinates mean X, Y. So I like to draw a picture of it. I'm writing my number using its polar coordinates. Now remember, the complex number is X plus YI. X is our cosine theta, and Y is our sine theta. So this is how I'm trying to write my number. And he's got the I out here in front. Okay, but it's the same thing. This is what I'm trying to match. So I need to look at my setup here. What's my R? You should be able to tell me what your R is. 2√2. So R is going to be 2√2. Now I need my theta. Well, ideally, you recognize that if X and Y are the same, it's pi over 4. So this angle right here is pi over 4. But the answer here is not pi over 4. The answer here has to either be this angle or this angle. Because pi over 4, the angle pi over 4 is in quadrant 1. Agreed? This is not quadrant 1. So I need to have a pi over 4 in quadrant 4. So I'm either going to use 7 pi over 4 or I'm going to use negative pi over 4, and it's multiple choice. So I just have to find the one that matches, and it looks like C. So, next time I see you, we have a little, just one side, one piece of paper, one side, 4 or 5 questions. just like this, where you are changing from rectangular to polar, that kind of stuff. Got it? All right, now let's get our notes back out. And we're going to put a graph in polar coordinates. Now, if you think back in your lifetime of math class, when you have been asked to graph something that wasn't familiar to you, so like if I put up on the board y equals 2x plus 3, you've graphed a million lines, so you would do that however. But if you had something that you didn't know what it was, can't we always set up a T-chart and plot points? So luckily for you, the T-chart has already been set up. All the thetas are there, and you're gonna find the R values. For the equation, R equals 3 minus 3 sine theta. So we are going to graph by hand this one time. And then I'm gonna show you how to do it on your calculator. But we're gonna graph R equals 3 minus 3 sine theta. Okay? And while I get things set up here so we can start plotting these points, I'm gonna divvy up the responsibilities. So how many have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have about 17. All right, so you guys in this column right here, I want you to do the first 5 angles. Okay? You guys are doing the first 5 angles. You guys are doing the next 6, and you guys are doing the last 6. Okay? So you are evaluating these without a calculator. This is your unit circle. So for example, just to make sure everybody's clear, for 0, you're going to evaluate 3 minus 3 sine 0. So you figure out what the sine of 0 is, and then do 3 minus 3 times it. All right, we're going to fill in your chart, and then we're going to plot the points. And you are going to be so glad you came to school today. It is going to be so cool.
I have my doubts.
No. Yes, you're gonna love this picture.
Oh, that you're making?
Yep. Well, all you're doing now is filling in the table of values. So guys, just fill in the table of values, and when you have your chunk, come up and put them on the board for me. Remember, you're only finding R, so it's 3 minus 3 sine.
It's root 2 over 2, and then it's times negative 3, and then we move 3 minus negative root 2 over 2. I found the common denominator is 2, and then you can multiply the first by 2. So this would be the equation. 3 minus 3 root 2 over 2 root 2, and then I just set it up like this. So this would be like that. 3 over 1, right? Oh, 6 over 6 over 2. It's all. Same amount, 6 over 6. I don't know how you graph that, but it's a good knowledge.
6 minus 6 root 3. When I multiplied that 2, I multiplied both 3's by 2 or no? Never mind. I'm confused myself. I'm lost too.
we can,
I think we did.
No, Mark got better today. He doesn't do it.
Wait,
Enzo, put them up on the board.
Do we do just the answers?
Yeah. They're just still
Oh, we're
on
not
the
even
table
graphing?
for your record.
Oh,
So
I
Cole, you do
thought-
your set. Fred, you do your set.
Maybe, I think I got us one.
You have it? Yeah, that's
We
Wow.
have to do 5.
Yeah. You're good. We don't.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Fred, you got 4, 5, 6, 3 on. So Cole, have you got him yet?
It's 6 minus 3
Alex, you got
root
'em?
2 over 2.
All right, did you put him up here?
Yeah. Yeah. No,
Oh, the whole thing.
thing's over 2. Yeah, it's like one term.
Oh, got a minus. White and minus. Because I have to plot it.
That's the same thing.
Wait, how did you do that?
I forgot. I thought we were gonna have to plot it like that.
Technically multiplying a -3 by it, making that negative, but then you still have the minus there, don't you? Right here, I did.
No,
Ben, you did bring up the third one? Third
Take
and
your
fourth?
turn. Take the other side.
Which is what we got.
What?
That's what we got.
For what?
Third and fourth one? I might have did mine different.
Did you not get them?
Well, it's 3 minus 3 root 2 over root 2. Multiply that root 2.
Show me your
side.
Wait, no, I think I did. We both did it the same way.
Because when I multiplied the root 2,
I think it's
or the 2 to both sides, it's 6 minus root, or 3 root 2.
I'm pretty sure the way you wrote it is right. It's just those sixes. I'm pretty sure.
I think, yeah, because if you're putting it over 2, you.
Well, no, because then you would be canceled. Because you
If
can't
you're like
cancel.
that, you're like that.
You can't cancel this whole thing.
But you multiply that by 2. And
Yeah, look, this is what this 3 is really saying. 3 over 1. 3 over 1 minus 3 is 2 can't subtract. We don't have to stop it. So we have to use 6 over 2
I'm pretty sure it's
That's my fault.
I don't think
Normally, like 3 over, it would be 3 over 2.
Yeah, honestly, you can say they're both right. And I think it's
Honestly, she's fixing something. Not all this stuff.
I think we're fine. Are we not?
3 minus 3?
Okay, Fred, what is this? What is this?
But we just found a common denominator.
You let all you did
I was thinking just
I think.
Because I think they're saying the same thing. What you're trying to say and what I was saying is exactly. It's just, that's the one-term answer.
Okay, I think we got a couple of bad ones up there. Over there on that side, what did we get for 4 pi over 3? What did you guys get for 4 pi over 3? What did we get?
3 plus 3 squared root of 2.
That makes more sense, yeah. 3 plus 3 square root of 3 over 2. Okay, what did you get for 5 pi over 3?
Same thing. 3 plus 3 root of 3.
Okay. All right, so we got a lot of repeats. You didn't notice it because you were just doing individual chunks of the chart, but there's a lot of repeat here. And of course, you understand why that is. What do we know about sine and cosine? Don't they have repeated values all over the place? So every time you do a pi over 3 angle, the sine is going to be the same thing, and the cosine is going to be the same thing. Now, sometimes positive and sometimes negative, so that will change it a little bit. But basically, you got the same numbers over and over again. All right, so here we go. Hold on to your hat. We're going to graph this. So,
No, we didn't.
0,
Man wrote it wrong.
angle 0,
I don't know if we did it.
radius is 3. So the radius is 3 right here, angle 0 is right here. Did you notice, I don't know why he did this, but see how his things are? So that means 3 is going to be right in the middle of 2 and 4, right? Okay, so that's our first point. All right, then we have pi over 6. Here's my pi over 6 line, and I'm 1.5. So pi over 6, 1.5 is going to be all in here. Actually, 1.5, that would be 1. But it's hard, just approximate it. And then I did decimals. So if pi over 4 is right, it's 0.879. And if pi over 3 is right, it's 0.402, and then pi over 2 is 0. So look what happened, guys. Connect your dots. I kind of missed that a little bit. But yours should be a nice rounded thing. Is that what you got when you connected them? Now we're going to start over. So now we've come this far. We did these guys as points. Now we're going to do these. Oh, I didn't do that one. Decimal. I didn't do that. Just a second. This is another 0.402. And that's going to be another 0.879. Okay, so here we go. On 2 pi over 3, I've got that 0.402 number. Yours is going to be so much better than mine, but it's right in there. And then I'm coming out to the 0.87 number. And then I'm back to 1.5.
Like, plug it into the equation.
And then I'm back out to 3. Oh my gosh, what happened? Did you get like that? Okay, oh, it's gonna get better, just wait a minute. So where am I now? I'm here. All right, so now I'm back, now I'm at 4.5. So at 7. All right, and let's label this is 7 pi over 6. Okay, so at 7 or pi over 6, I'm at 4.5. I'm coming out now, I'm growing. At 5 pi over 4, I'm at 512, and again, I am assuming that these numbers are right. And then I'm at what? What was that? 3 plus 3 root 2. That was 3.8 again? That's not right. Okay, we messed up some of these numbers over here. Can somebody correct any of these for me?
What?
Oh, maybe not, maybe I skipped these. All right, so that, have I done that one, 5 pi over 4, yep. Then this one, what was this one? What was 4 pi over 3?
Not sure.
What's the sine of 4 pi over 3?
Yeah, root 3 over 2.
Alright, so that should be, maybe I typed that in wrong.
should be the same as the 5 over 3 one. No, I'm wrong.
So it should be 5.598. And that one's 6. All right, so this one's a little bit bigger, and this one's all the way out to 6. There we go. Okay, that's better. All right, so now I'm ready for another 5 point. No, that would be this one's 5. So 5.552, 4.5. And back to 3. Looky there.
Peach. Supposed to be hard.
Well, its mathematical name, there are 4 classical curves that we're going to look at. Well, we may not look at all of them, but we'll look at a couple of them anyway. This is an example. This type of an equation is an example of what's called a limousin. And if these, so limousin, I always think of lima bean. Lima bean. Some of them will have an interior loop in them. This one does not, because these 2 numbers match. One's positive, one is negative, that's fine, but they are the same number. When that happens, you have a special limousin called a cardioid. So this is a cardioid. Depending on whether that's an addition or a subtraction, or if it's a sine or a cosine, the heart, the indentation, can be on any side of it. So it could be sideways. It could be upside down. That depends on whether that is positive or negative, and whether this is a sine or a cosine. And we're gonna explore that a little bit when we get to our calculators. But for now, there you go, your very first polar graph, okay?
It could be like literally any angle.
Yep.
Any-
Well, ours are all gonna be either a heart like this, a heart like this, a heart like this, or a heart like this.
So
Ours
not
is
like
not gonna be
45-degree
slanted.
angle.
They're gonna be on an axis.
Oh, you did see me.
All right, so let's graph this on our calculator real quick. And then we're gonna look at the next couple multiple choice questions. All right, so got our calculators on. We're gonna go to mode. Our calculator should automatically be set in radians, and then we're gonna go down. And instead of function mode, we're gonna click over to POL, polar mode. So we're in mode, we're in radians, and we are in polar. All right, now we're gonna go to window, a regular old window. Okay, and theta min is going to be 0, and theta max, or I should say, wait a minute, just, I didn't change the polar. Okay, so we're gonna go to window. Theta min is 0, theta max is 2 pi. Why am I using 2 pi? Because that's the period of the sine. This is a sine. If I do more than 2 pi, I'm just gonna keep going over and over and over. So 0 to 2 pi, good. Theta step. I think the default is 0.13 something. If it isn't, make it like 0.1. We'll talk about what that does in a minute. But if it defaults to 0.130, whatever, that's perfect. If you have to manually change it, make it 1. Now, X and Y. We have the luxury of already having graphed this. So a good X and a good Y might be like -7 to 7. That would give us a little cushion. So for X and Y, we're gonna go -7 to 7. If you don't already have a graph, you'll have to play around with it. But since we already have it, that's good. Now, go to y equals. And now when you press y equals, it doesn't say y equals, it says r equals, because that's the way your equation is written. So r equals 3 minus 3 sine theta. And theta is your x button, the variable button. Now it's theta because you switch modes. All right, hit graph. And you see what we see. Now, I don't know if we talked about this before or not, a little trick. Your screen is rectangular. So things are always, anything you graph, regular graphing or polar graphing, anything you graph is warped a little bit because of a rectangular screen. So if you hit zoom square, that will square your screen and give you a little bit more accurate view of the picture. Okay? Now we're going to be doing more of that. That's all I'm going to do right now. But that's how you graph polarly. Please remember, next time you pull your calculator out, it's in polar mode. So if you're doing something with x's and y's, you're going to need to change it back into rectangular mode.
Mine's not graphic.
Of course it's not. We'll look at it in a minute, but we got to do a couple more problems. All right. As of last year, I don't know about this year. I haven't gotten any indications yet. But on the AP exam, I'm reading this straight out from Mr. Passwater's notes. No one has to graph by hand a polar graph on the AP exam. However, you have to understand the graphs well enough to do multiple choice questions without your calculator. Okay, so you need to have an understanding of the graphs. So let's look at how this works. Example 2. The picture is there. You need to figure out, without a calculator, this is a no calculator question, you have to figure out which of those equations, like this was the one we just graphed, this looks like that, which of these equations would match that picture? Does anyone have an idea of how you could easily determine? Well, I like to pick a point that I am very comfortable with. So on the graph, I am very comfortable with the point 3, 3 pi over 2. I'm not estimating that point. I'm very confident that point is on my graph. Would you agree? Right?
Yeah.
So what that means is, let's look at example A. 3 sine 3 theta. If I put in 3 pi over 2, then I should end up with 3, correct? So let's do it. 3 times 3 pi over 2 would be 9 pi over 2. What about 9 pi over 2? That's kind of big.
This is pi.
It's just pi over 2. And what's the sine of pi over 2? 1. So did I end up with where I was supposed to end up? Did I get the right R value? Yeah, so the answer is A. Just for fun, let's try another one. Let's try C. Let's try C. 3 cosine 3 theta. If I put in 3 pi over 2 into equation C, I'm going to have the cosine of 9 pi over 2, which Cole says is the same as pi over 2. Now, what is the cosine of pi over 2? 0. So I don't get 3, I get 0. See how that one doesn't work? And how did I check it? By simply plugging in a point. Now, if you do enough of this, practice enough, you might get to the point where you can look at the equations and make that determination. But one way is simply to pick a point that you absolutely are sure of, not one like these that I'm estimating, but one I'm sure of. Plug in the theta and see if it gives you the right R. Okay? All right, I'm gonna stop there. We'll pick up there tomorrow. It's in the equation.
Oh, and I think you will. There, you can go tonight, let me know.
What are they normally?
Yeah.
Like,
I hope I get someone that I can like actually.
20, 25. Yeah. Probably like, no, I'm actually how much time are you? I have the cash.
I know, I should be fine.
That makes sense.